Hello, I'm John Janowick. I'm Executive Director of ECEDHA, the Electrical and Computer Engineering Department Heads Association. Thank you for joining me today for the ECE Spotlight webinar. ECEDHA is the premier academic association of electrical and computer engineering and other related fields. The ECE Spotlights have been designed to provide industry a direct voice into academia, showcasing their innovation and educational tools. Now, I would like to welcome Sunny Ray, Academic Solutions Advisor, to present Quanser's ECE Spotlight webinar.
Good morning, ladies and gentlemen. My name is Sunny, and it's my pleasure to have this few minutes with you to be able to share how Quanser enables educators, engages researchers, and empowers industry to engineer a brighter future. We've been in this, I wanted to just start by mentioning that our company is academia. Our focus 20 years ago when Dr. Jacob Abkarian started our company, he was a professor that saw the disconnect that students had between theory and application. And it was something that he had seen. This business actually started out of his basement, and that same type of innovation and love for education has transpired through our companies and our distributors alike. Our world today is plagued with the energy crisis, we've got the financial crisis, we've got the healthcare crisis, we've got security crisis. I just turned 30 the other day and I feel like we've got all these crises to solve and I don't really know where to start, so I'm hoping this room will be a beginning. This presentation today will talk about enabling educators, our core strength as a company. For more than 20 years we've been outfitting turnkey mechatronic controlled training system labs for universities like yours. I'm going to talk a little bit about how we engage researchers to tackle some of the grand challenges of tomorrow. And last but not least, I'll also talk about how we empower industry. So if you remember nothing else, there's 3 words that maybe you'd like to walk away with from this presentation. It's we help you captivate students, we help you motivate your students once they're in your program, and third, we help you graduate better students. Mechatronic engineering. So there's been a lot of talk already about the importance of systems thinking. Thomas Friedman talks about it. Seems like every article nowadays in the paper talks about how we need a systems approach to engineering. It's not enough. When I did engineering, I did electrical engineering, and I understood a very finite part of engineering. And I think as years go by, we realize that systems are becoming more and more complex, and a mechatronics approach is really required at the end of the day. So what is mechatronics? I'm sure many of you already know this, but I love this diagram because it describes it really nicely. So it's where computers, mechanical systems, electronic systems, and control systems come together. And so before I began the presentation, I wanted to just quickly bring attention to something that really blew my mind. Many of you have probably heard of Raymond Kurzweil, and he actually shows this slide in his TED videos and many other videos, and he talks about the growth of computing. He talks about how it took us 90 years to be able to do 1 MIPS per every $1,000 of computing, and today every hour we increase our computational power by more than a MIPS. So MIPS, by the way, is the number of calculations a computer can do per second for $1,000. And what this graph here shows is it shows that back in the 1900s we're able to do 10 to the minus 10 calculations per second, and today we're able to do a lot more than that. And the key thing to note here is that this is an exponential graph. So what you're seeing here, even though it looks somewhat linear along this line, this is actually an exponential graph. And even in that exponential component, you're noticing there's also an exponential acceleration to it. So the message here is that what Dr. Kurzweil mentioned is that by 2030, $1,000 of computation will be about 1,000 times more powerful than a human brain. 1,000 times more powerful than a human brain. And in the previous slide you saw by 2030, a $1,000 computer will have the computational power perhaps of all of humankind. That's a lot of power in our hands, and I think it's important for us to guide the future of engineers in the right direction. And I thought I'd mention that. And by the way, Dr. Raymond Kurzweil, along with Larry Page from Google, along with Dean Kamen, they all sit on a group of, they recently have a website online. It's part of the National Academies of Engineering, where they've listed the grand challenges of our century. And I encourage all of you to visit that if you haven't done so already. And in there, he lists a myriad of different areas that require attention, whether it be solar energy, whether it be scanning the brain. There's about 10 or 12 different areas. Our company, over the last 20 years, we've had the pleasure of serving more than 2,000 universities around the world. I've been to IIT, I've been to MIT, I've been to Harvard, Stanford, and I've had the pleasure of being able to walk into some of the most innovative labs where some of the most innovative things are taking place. And I wanted to share that. And with that said, I'd like to get into the bulk of the presentation. So enabling educators, how do we go about doing that? So over the last 20 years, our company collaboratively works with universities to build mechatronic systems, so systems that include the computer system, the controls, whether it be sitting on top of MATLAB Simulink software, whether it be working in conjunction with National Instruments. We develop full turnkey systems that give your students hands-on experience into different fields. So here you see the 2D helicopter. We have about 3 or 4 different helicopters. We've got 5 or 6 different earthquake shake tables. That blue one right there alone is part of the NEAS consortium by Dr. Shirley Dyke, and it's used in over 130 different universities. They have, anyways, I can talk about that forever. But we have a lot of different systems out there that, whether it be robotic systems, whether it be, and the system that it actually all started with is this rotary servo system. It's a very simple system, but it's one of the most basic systems that students need to get themselves comfortable with before they can move on to some of the more complex systems. So we say, if there's 2 or 3 things that I could really emphasize in terms of our product line, number 1 thing is modularity. Number 2 would be open architecture, no particular order. So modularity, really what that means is that when we come in to equip a lab, there's 4 critical components that you need to be able to finish a lab. So you've got your plant, you've got your hardware, you've got your software, and then you've got your curriculum. But now what we try and do is we try and keep all the other things as constant as possible. So the power modules, the control cards, the software, we try and keep it all common denominators so that when you're changing your lab or when you're developing your lab over a 5-year period, you're not having to reinvest money into buying all the core components. And as a result, you can focus on, like I said, whether it be a laser beam stabilization experiment, whether it be a helicopter, whether it be an earthquake shake table. And the context of today's presentation is really to encourage deans and chairs like yourselves to really look at, and many of you are already doing this, but to really look at and consider the importance of combining different departments together into one lab. And I'll be speaking a little bit about that in terms of the potential cost savings, in terms of the potential value add in putting together different engineers from different departments. That's the future of engineering, is electrical engineering work in Canada or US working with a guy in China who then goes online with a guy in India and they build a product in less than 24 hours. I mean, that's the type of world we're coming into, and that's the type of labs that some of the leading institutions, I believe this one is at Queen's University, but many of you probably know Dr. Mark Spong. He speaks about this. He built an integrated learning center at the University of Urbana-Champaign, Illinois. And so the idea is pool several engineering departments' resources. You get more out of your lab activity with reduced amount of overhead to building, running, and maintaining your lab. So what does that really mean? So usually when I go to universities, I'll walk over to the mechanical engineering lab and they'll have PC, they'll have software, they'll have data acquisition cards, they'll have amplifiers, they'll have lab space. And then you go over to the computer engineering, then you go over to the aerospace engineering, then you go over to the electrical engineering, and they all have a lot of equipment that's exactly the same. So what we're suggesting is wouldn't it make more sense to kind of bring all the common components together in a way that allows you to invest more money in some of the hands-on leading technologies that your students could get exposure to, whether it be, like I said, a helicopter, whether it be an unmanned air vehicle. We have a lineup of unmanned air vehicles and ground vehicles now as well. But really the key is, so let's say you have a civil engineering lab here. you roll in on a shake table, and then the next hour, and then the next day, you've got an electrical engineering professor who wants to use a rotary system with an inverted pendulum. Well, you can do that, and you can do that by consolidating your lab. And then maybe in the next lab, you've got a mechanical engineering professor who wants to do some testing or wants to do an experiment with a linear inverted pendulum. Well, you can do that now. And by the way, I should also mention, when I say modularity, I don't have enough time in this presentation to really go over it, but this inverted pendulum that you see up here, or the linear system, is actually the base for maybe 10 or 12 different modules. So you can turn that into a seesaw system with an inverted pendulum. You can turn that, you can do linear flexible joint, you can have springs, you can do spring mass systems. You can do a lot of different things with it, but in the interest of time, I'm just going to kind of zip through this. So you've got, I should have just put a picture of me when I went to university, because I was so frustrated. I had such a hard time just looking at, I think MATLAB Simulink is a great and powerful tool, but when that's the only thing you have to look at, all of a sudden things like damping and things like any PID control theory, all that just becomes things you need to memorize instead of things that you truly understand. In my first job, I was working at a hydrogen fuel cell company. And my job was to control 2,000 liters per minute of hydrogen to a fuel cell producing, 200 or 300 volts. And the truth is I had a really hard time getting around that until I started my job here at Quanser 5 years ago. My understanding of control systems and mechatronic systems was very limited. And I'm a sales guy, so now 60% savings. And any of you who are interested, I have about 15 or 20 packages here, and we've got detailed documentary, if you'd like Excel files to prove that you can save up to 60% of your money by consolidating labs. I can go and show you that as well. Effective use of space, new technology, and more workspace. And at the end of the day, you get better students out of it. That's the main goal. The next component of the second part of the presentation, I wanted to share a little bit with you about how we engage researchers. So although our primary focus, I'd say 80% of our company's focus up till date has been focusing on the academic market and really working with professors to be able to engage students more effectively, engineering students. What's kind of spiraled out of that in the last 5 to 10 years is we've now built a strong network of researchers around the world that we work with to develop the next wave of technology. So in our it didn't come out too nicely, but 62% of our company, actually we have 62% of our engineering team works on collaborative projects, whether it be with government researchers, but mostly university professors. And we have a highly qualified team of engineers that can work with you and your department to develop proposals that get passed. We're kind of at the node of a lot of different universities, so we're seeing what's working for some universities and we're seeing what's not working for others. So by having a conversation with us, you can perhaps save a few years in terms of getting funded. And again, we don't know everything when it comes to it, but we'd like to learn from you and really have that exchange and be able to take innovation to the next level. So just to give you an idea of how we work with a professor, this is just recently, last year, Dr. Venkat Krovi came to us, and he mentioned that he was working with I believe it was a biomedical professor. Anyways, they were trying to simulate a saber-toothed tiger, so the jaws of the saber-toothed tiger. And they had taken a look at some of the 6 degree of freedom hexapods and different systems that were out there, and nothing really fit their need. So he came to us, and within, I believe, 2 or 3 months, he worked with our engineering team, and we were able to put together a fully functional 6 degree of freedom hexapod to simulate a saber-toothed tiger's jaws in a matter of, like I said, months. And again, I think that's attributed to our team, but it's also attributed to the mechatronics process, to the process that our engineers take to be able to design a complex system like this. And it's not just about understanding electrical engineering or computer engineering. It's about designing all these different systems together. So oftentimes our engineers will have a kickoff meeting where we have all 5 or 6 engineers in one room. And that process, I believe, truly is our core strength as a company. So over the years, we've developed and we've worked alongside companies such as KUKA and Denso and CRS. And we offer these industrial robots as research tools. So industrial robots by nature are not very great research tools because they're usually closed architecture. So with our with MATLAB Simulink and our Quark software, we enable you, we give you access to all the encoders and all the joints and all the motors. We give you full insight into everything. And that's really, really powerful. So we've worked with these companies over the last few years to be able to offer you that. Just to mention here that we also work with, many of you probably know Sensible. We've worked with them to release this Omni Bundle tool, which again, it's a great tool for teaching robotics. If you guys have robotics departments, and I'm sure most of you do, it's low cost, but the curriculum that's developed around it is amazing. It touches forward and inverse kinematics. It goes into the whole range of what you need to know to be able to move on to more complex systems. So just some of the different areas that we've worked with researchers, needle insertion. So we have about 50 to 60 different haptic devices that we've developed, all the way from 1 degree of freedom to 6 degree of freedom solutions. And needle insertion being more of a 1 degree of freedom system. Here we have a surgical robot that we worked with professors again to release. And this is actually a surgical robot. This is an open architecture telepresence system. So where you could have this system in, like I said, here in Florida, and you could have this CRS robot in the middle of a battlefield, and you could have a doctor potentially in the future perform surgery remotely. Oh. Rehabilitation, this is another area of a lot of investment and energy, time energy for our company. This is more of a 2 degree of freedom simple system, but because of these projects, we've now gotten involved in Toronto. We've gotten involved with a very large project, the SEAL project, which is actually building a hexapod the size of half the size of this room. And inside this room, they're going to have bikes, they're going to have treadmills, and they're going to have all these different systems, and a 3 degree of freedom crane system that's going to hold the patient up from up above, and a fully virtual immersive system where the post-stroke patient or whoever it is can relearn how to walk on ice or walk on whatever. And those are the types of projects that we're getting involved with. Again, I believe it's attributed to their mechatronics background. And then not to mention endonasal surgery as well. So just to shift gears here for a second, this is an example of a collaboration that we had with the Canadian government. This was related to a collaborative control of unmanned air vehicle, unmanned ground vehicle. So there's actually a series of robots that work together, again, totally autonomously, using MATLAB Simulink, and where one of those two UAVs actually flew over an area, identified a tarp, and then sent a blimp to go check out the area, and then the blimp sent 2 unmanned ground vehicles to drop 3 more robots. I mean, again, our goal is not necessarily to do the research, but it's to provide you with the platforms that you need to be able to innovate the next wave of innovation. And really, I think there's a lot of talk right now about innovation in the news today, and everybody's talking about it. But I don't think innovation is anything special. I think innovation is really about knowing a lot of things about one thing. And if you know a lot of things about one thing, then for you to invent the next great thing is a lot easier. But if you don't have access to the internet, like most of the world, if you don't have access to these tools, then what happens is we end up reinventing the wheel. So that collaboration then led to us actually launching a whole series of indoor unmanned ground vehicles and air vehicles. So that's a cue ball. That's a cue ball. So we've been developing that for a few years now, and it's a quadrotor with a metal cage around it that's safe for indoor use. It's perfect. It can hit up against the wall. Two of them can collide against each other, and you're still okay. Whereas with most helicopters, one crash and it's game over. And then we've also worked with iRobot to take their the vacuum cleaner. I'm sure many of you have seen it. So we've taken that and we've put eyes on it. We've got sonar sensors and a whole whack of sensors. We've got a Gumsticks PC inside of it, and using our Quark software and Simulink. So you just sit there in Simulink, you design a controller, you click a button, and all the C code gets generated in the background, and boom, and now you're controlling systems. Very exciting. So the last piece I wanted to finish off with here, I think I'm probably nearing the end of my talk, is empowering industry. And really, when I put these last few slides together, I wasn't really sure where to go with it. I could have gone in a lot of different directions. But I think the underlying message is at the end of the day, we help you graduate better students so that when they're out in industry, the reputation of your university gets noticed, and at the end of the day, I think that's one of the things that we're all striving for. But just to take a step, Dr. Mark Splongwinch, I like this quote: "The 21st century will be known as the age of automatic control." So the 21st century will be known as the age of automatic control. So if we know that's the fact 100 years out, looking back, we're sitting here right now. So we get to invent this future, and I think it's just incredibly exciting. So some of the major issues, I started this talk by talking about, energy crisis, you've got population, you've got all these different issues around the world, and although I agree that, policy is going to play a big role in all of this. I think changing the mindset of people is going to play a big role in all of this. But we know from our history that those things don't move very quickly. I think the real solutions for our future is really going to lie in collaboration and in innovation. And through innovation, I think we'll be able to reinvent our future. And we're doing that. We're not as big as MathWorks. We're not as big as National Instruments. But we work with these companies, we work alongside these companies to really be able to invent these new products and to really bring them to market, so that when your students are working on a system, they're working on relevant systems, they're using software that matter, and they're out in the industry up and running. So one of the last points is, over the last 10 years, we've also built up a distributorship. We just had our first annual distributor summit actually last week. We've got about 30 different distributors in different countries. We've got 20 agents as well. In fact, one of our distributors that we just took on is ECEDHA in India. They have 200 employees in their company. So we work alongside these distributors to not just as ways to get our product to market, but also as a way to get feedback from the market, from a global market. In the last few years, our company has actually grown much more significantly outside of North America than it has in North America. And so one of the initiatives that we're taking, and right now as a company, is we're actually looking to build a community of researchers. What happens is oftentimes a professor will buy our servo, or they'll get our QNet system, or they'll buy a robot, and they'll develop curriculum around it, or they'll release a paper on it. But a lot of that information we're finding is kind of just all over the place. Our goal is to kind of bring that together now with the internet and with all the tools that are available to us. I think it's going to be a lot easier. But you're going to start seeing a much more community development approach amongst ECE researchers and engineering professors in a way you haven't seen before. And just to finish off, captivate, motivate, graduate. That's where our company started, and that's where we're going. So hopefully we can do it with you guys. Thank you for your time.
Thank you, Sonny. This concludes our Spotlight webinar by Quanser. Thank you for attending, and stay tuned to ECEDHA at ECEDHA.org.